Hello and welcome to Tech Simplified TV and a very warm welcome to the Semiconductor Podcast. We are back with another exciting episode with another startup founder, Mr. Marmik Bhatt from Gujarat. Welcome, Marmik. Thank you
Thank
very much for accepting our invitation and coming to the Semiconductor Podcast. Okay,
one.
so Okay, so let's start. You are the star of this episode. So start your journey. We will start with your journey. How you started? How you started? Why you? What's your vision behind Monk Tech and specifically the name, technology and Monk? How these two things came together? Tell us the story.
So it's a wonderful story. I have been tech enthusiast from my, primary education. In 1995, I belonged to a tier 2 city called Rajkot, and I grew up here. In 1995, I, started learning computer for first time in my life, and my school taught me the very old technologies like MS-DOS or Fox Pro and Basics and Pascal and those kind of languages. Then I did my bachelor's in computer applications, but at that time I had to support my family, so I did MBA. Because of MBA, you get job very easily and you get good salary as well. But I was keep pushing myself for a really good technological access. But there things happen during my life, so that change the course of my career, and I end up in semiconductor. In 2015, I was a product developer, and I had to create equipment where I required ASICs. So I started learning the VHDL, then Verilog. But then I realized to once you want to fabricate your ASIC, you have to keep yourself dependent on some of the EDA tools, and you also are dependent for licensing some of the technologies from some of the big fabs. And you have there is a kind of a monopoly by IMAC and Europractice, particularly in India, if you want to do a MPW with. So I found that it's possible to have an ASIC, but it's not that simple to fabricate. So I started learning few things. I met a person called Sam Ziloff. He created a small lab in his garage, and he was fabricating some of the basic designs at micron level, not nano level. So that started my curiosity. With my own investment, I utilized some of the academia fabs and nanotechnology labs where they process some of my wafers. So initially, I send them blank wafers, and I give them the parameters like I need nitride deposition, I need oxide deposition, I need metallization and metal deposition, and such parameters. And those things went really nice. In 2018, I were able to do some circuitry at 500 nanometer critical dimension. And then in 2018, same year, I was also able to do some projects in 180 nanometer as well. But
Big leap.
Right.
It's a big leap.
Yeah,
500 to 180.
but I didn't had any facility at that time, right? I was dependent on nanoscience and academia fabs. I have to send them my samples. I have to wait for that samples to be processed in scanning electron microscope. Some of have to be destroyed, say, for the characterization and metrology. But that was successful, and at that time I started identifying some industry veterans who can help me build a recipe. So my vision was to give India its own TSMC. So India doesn't require to partner with any company for technology. We can build our own technology. If you look at the background of Tata Institute of Science, which is called IISc Bangalore, or you look at the history of ISRO, sometimes we had external support, but then we sorted out on our own, right? So
Exactly.
that's what we wanted. So now Monk Technology has its own recipe to process 350 nanometer, 180 nanometer, and 130 nanometer technology, right? So this is how it was started in 2015 and 16. And during pandemic we researched really more and converted this science project into a business model. So we
Great.
identified the missing gaps. So when this 350 nanometer and 180 nanometer, there's also a story why we choose those nodes. So initially we decided that let's identify the gaps in the market, and 50% of the node technology are legacy nodes, right?
Mm,
350
mm,
technology. So, and India imports very huge quantity for such kind of technology from other countries. So there is a really good market for that. That's why, and also it's comparatively easy to process. So
mm,
we decided that when this technology were introduced, there were some process steps which require very high temperature processing, like thermal ALD. Then you have LPCVD. Sometimes it goes around 900 to 1100 degree centigrade
mm.
for oxide position. We choose legacy technology, but at advanced cutting edge processing like plasma enhanced CVD and reactive ion etching. So that not only reduce your raw material consumption, as well as it also improves the processing time,
Performance.
performance.
Performance at the legacy node. Yeah, that's a very wise decision. Very
Right.
clever step.
Right, and again, it also reduced the requirement of multiple equipments, right? So you
Mm,
can usually what fab has is dedicated equipment for each of the process, or sometimes multiple equipment for single step, right? So Monk Fab has the lowest capital investment. We use refurbished equipments to save the money, and we also
it's a
use
good thing.
equipment for one process. So so basically the capital investment was very less, and due to introduction of this advanced technology, our operating cost was also reduced. So we were able to provide the service to our customers, which is way more price compatible with all other options. And right now, if you want to manufacture your ASIC design, right, the minimum cost is in 50 lakh or 80 lakh rupees, which it starts from, because you have to buy license, then you have to wait for MPW shuttle, and then you have to pay per square for your MPW, right? We have like kind of a really nice setup where we use open source EDA tools, right? And during this conversation, I'll explain how that makes a huge difference. And then we have a direct writing lithography sometimes, so that reduces the requirement for mask creation. So the overall cost is reduced at a very substantial level.
Great.
You asked like why Monk and
Yes.
technology, right? So the component of Monk came from my habit of supporting Ramakrishna mission. So I was a volunteer for Ramakrishna mission from like my childhood, and I have read Swami Vivekananda from very beginning when I was able to read something. And then I like in his famous speech, he said that I come from an order of the oldest order of the monks in the world. So that word stick in my mind, that monk is very recognizable word throughout the world, and we wanted to make a organization which can last for second generation, and it should have presence throughout the world.
Wow.
That's why we immediately registered this trademark. And nine was just for registering the company. Nine would be removed. It would be only Monk Tech in future.
Okay.
So this is how everything started. And right now, we may be, I'm not sure, but we may be the most unique semiconductor manufacturing startup in the country right now.
First of all, I would say your decisions you took very very practical decisions. Legacy notes. Hello,
Right,
Mamik. Yeah,
right,
legacy notes and advanced technology. That's
right,
very good thing. I mean, legacy node has some benefit. You are
right,
taking that and making them very perfect, very
right,
precise. Precision is high. So
right,
performance wise, it's good. It will give you an edge as a
right,
business. That's good.
right.
And that approach is very very wise and clever approach. Very good. Another thing is the name. I'm really impressed. I'm from Narendrapur. Narendrapur, the name is after Swami Vivekanand. There is a big setup of Ramakrishna Mission. If you know, Narendrapur Ramakrishna Mission has a premier academic institute, school and college, both.
Right.
Premier academic institute. They
So
even they
if
train farmers. They
yes,
train farmers also for advance those dragon fruit and everything for new
absolutely.
technology in agriculture. They train for
And
them.
if you look at the history, the Tata Institute of Science, which we call it IISc Bangalore, was inspired by Swami Vivekanand to the Jamshedji Tata on his voyage from Japan to USA. There is a
Yeah.
really good story and a
Yes,
letter.
I've read somewhere.
Right? And you want feel it normal that I have been taught by monks. So there is a monk called Swami Krishna Sakhanand who taught me artificial intelligence. He is also editor in Ramakrishna Mission magazine, and
Yeah,
there
very,
is
very educated monks are there. I know.
right.
Very
And
educated, all
a
of
monk
them.
called Atmapriya Nanji Swami is in
Hmm.
Belur Math, and he's also the head of RKM Very University. Himself, he's PhD in quantum physics.
Oh,
So, so monks have the knowledge, and this knowledge you cannot even buy through like online courses or anything. But I
yeah.
still
Actually, from very young age, I have seen the kind of impact they have on society. Because I come from a place which is very, I mean, poverty was there, so many poor. Actually, Narendrapur, the place, the name is after Swami Vivekananda. Narendranath Dotto, it was his name when he was in family life. Later, he became monk. So, I have always seen camps and regular kind of. I mean, I have seen. There was. I just share a small story. Uh, Two brothers from Bihar. They are basically barber. They came there. They are connected. Okay, cobbler. Two brothers. I used to address them as uncle because they used to address my father as dada, big brother. One of their kid was excellent in painting. We call them with respectfully Maharaj. Maharaj noticed that and took up all the responsibility of education and all. That boy was senior to me, so I used to address him as Dada. That Dada got enrolled in art college in Kolkata, and now he is a professional artist. His father was a cobbler. Now he is a
right.
professional artist. That's kind of empowerment, and they
Yeah,
don't look at the whether you are Hindu or Muslim or Christian. No, if you need empowerment, you will get that.
exactly. And
That's the beauty of Ramakrishna Mission.
that is really needed in this era as well. Like a lot of people think that if you're from IIT, you can do deep tech. That is a dogma we have. That is a mindset we have, and that is completely wrong. Right? Anyone who have the learning ability, you should provide the platform, and that is
Yeah,
why Monk Technology, do a lot of education activities. So far, since 2021, we have taught around 3,500 students how to make their ASIC from scratch using open source tools. And
great.
like it's a recording, I can assure you we have never taken single rupee from student or institutions.
Great.
3,500 students already being taught, and our target is 10,000 students by 2027, and 100,000, 1 lakh students by 2035. So, the change in the industry from IT to hardware is moving. So that we also need to, make sure the workforce is also ready with that skill, right? So
And
for that,
that's your contribution to Atmanirbhar Bharat.
absolutely. And I would be doing even after I retire. I will keep doing that.
That's a exciting job to do. We are enjoying. We have very less money, but we are enjoying our work from
Absolutely.
Kolkata. That's why we moved to Kolkata because we don't have to pay the rent, and Kolkata has a very low living standard. Is expense is less here, so we moved here, left job and doing all these things. This tech simplified, so we moved to Kolkata.
No, that's
Great.
good. And
So your story is great.
right.
And you make another challenging thing. You shifted from computer application to this ASIC and mostly fabrication. It requires huge amount understanding of huge amount of physics. It's not very easy to understand.
So,
So
if you look at the fabrication, it is a combination of physics, chemistry, and electronics, right? So, you need
yes,
to understand
yes,
electronics. You also need to, and also mathematics. So, you also have, proper understanding of chemistry as well. And now the processing
yes.
is going towards plasma. So, you also need to have a very deep knowledge of physics as well. But if you try to find, you'll able to find all the knowledge you can have.
So while you were preparing yourself for all these subjects, you took help from anyone, any specific teacher, any specific professor, or you do it all yourself with books and contents? What? How did you
So,
made it?
of course, books help, but at certain point of time, you need someone to,
Yes, guide.
grab your hand and put you on the right direction. I
Exactly.
have been fortunate that wherever I ask for help, I receive the help. There are people like Dr. Greg Baldwin, and there are a lot many people like there is E-fabless co-founder is Mohammed Qasim. So these guys, whenever I ask something, they help me out with the technology. Then I created one habit that every day since 2021, I have been reading at least one research paper and one patent every day. So I
Great.
created a habit, and I have crossed more than 1,000 by now.
By now.
So, and then I was identifying the missing pieces throughout those readings. But of course, what to read have been taught by a lot of industry experts, and maybe this few people, as I told you, like artificial intelligence was taught by a monk to me. He was a
Maharaj, yeah.
right. So I was not worry about asking anything. Like I can ask TSMC CEO for anything. I don't have any shame on that, right?
Yeah.
Regardless of where you
Whether
belong, lot
they
of people,
accept or decline, it's up to them. But at least you are very clear to your conscience that at least you have tried. You have tried to reach him.
exactly. And then I found that those who actually know, right, they definitely help you out. Those who don't
Mm.
know will, try to move you away from your,
Mm.
actual goal. But those who really know the industry,
They
they
love
don't.
to share.
They love to share. Yeah, they those who really know, they love to share. So the actual knowledge is free of cost, right? In many ways.
And when you are very honest and very dedicated to some big target, big laksh, universe is there to help you. I
Right.
strongly believe that.
Right.
Everything will fall into place. You will. I mean, there is someone watching us. I
Right.
am.
A lot of people ask
Deep.
us that your background is not semiconductor and you're building a fab. So I said that even the people who made the first fab doesn't had the experience of making a fab, right? So some at some point you learn, and then you create a really good things, and you also learn
Those
from others' mistake.
exactly, and those who were for last 20 years, those who are in semiconductor now they need to learn about AI.
Right. Right.
And after 5 years, something new will come up. We have to
Yes.
learn it.
So basically, if you look at in VLSI,
Obviously,
I have seen a lot of students using ChatGPT to write VLSI. Their RTL from ChatGPT, then put it in the RTL to GDS flow. So already AI has started doing the chip design part. Maybe in future, chip fabrication will also done by AI.
although the policy and decision making will depend on us.
Absolutely.
Because and how receptive and how responsive AI will become, that more engineers will contribute in that to make it more responsive.
Absolutely.
So there the manpower will go in that way. So
Right.
you have worked with eFabless and about this open source thing. In our last episode we had episode with Shumanto Kaur from IIT Mumbai, IIT Bombay. The first team, he's the manager working with Professor Kanan Maudgalia sir. They are doing excellent job, amazing work they are doing. So we have our own open platform thing also, and it's so encouraging because small designers, small developers, those who don't have so much money to get license from EDA companies, they can take help of open source tools, and that culture must be cultivated in our country more.
Right,
and
exactly.
that is very very dominating in Europe. It's very common. So many people are there, they are working in every aspect, I mean PCB design to all. So they are taking. So how was your experience with efabless?
So E-fabless is a really good turning point in my career. When I was researching about ASIC, I come across a guy called Matt Van from Zero to ASIC. So he was the head
I
of
know.
Bosses, and then we discussed about few things. He introduced me to E-fabless corporation, and I was surprised that with very less effort I can create the whole system on chip. So the Muhammad Qasim, I call him the genius. He, told Google to make Skywater technology, which was Cypress previously. So he told Skywater Foundry, Google to fund Skywater to make it open source, and that changes everything, right? So they also created a software called Open Lane from Open Road Initiative, which is open
Mm,
source EDA tool. So without any license, just with your RTL skill, you can do RTL to GDS flow, the whole ASIC flow, right? And you were able to create your GDS2, and you send it those GDS2 to foundries, and your chip will be, fabricated. And Google initially funded around 648 uh, free tape outs, out of which I guess 255 took out from India, and some of them were very successful. I have seen lot many startups emerge because of eFabless Corporation. And I told my dreams to Mohammad Qasim, is the chief technical officer of eFabless, and he encouraged me to start the Monk technology.
wow.
He also guided me very well on those things. So when I wanted to create my own first ASIC, I was researching lot many things, but then I realized that eFabless is the platform which is not available anywhere. Like, you don't have to purchase PDK, you don't have to purchase EDA tool. You just have to work on your on design. I was already working on VHDL, and initially I created very small designs like 7 segment displays. Then I started learning how to control GPIOs. At some point of time, I started making ALUs, and then 4-bit CPUs, 8-bit CPUs. Then I also learned how to create your PLL, and then how to create your wishbones, and then I learned the peripherals and protocols. But the platform which helped me to do this are like done by the eFabless Corporation. And also, like, this is a very nice community. In India, it's also a really nice community. People like Kunal Ghosh is contributing really nice in
Very.
this. And then we have lot many people from CDAC helping us
Mm,
at lot many front. So open source thing helped me to get at that level. Otherwise, I won't be able to purchase license of any EDA tools, right? That I was not been able to do that investment initially, and I might not have entered into semiconductor at all if these things were not available. So, like, just this morning I was also having chatting with eFabless people as well. So that's like lifelong connection with eFabless
yeah.
basically. Yeah.
And have you talked to Team Edward, part of efabless, I guess? I mean, he has
We had, yeah, we had many meetings together, and yeah.
actually he has there is a tool called NetGen for layout, open tool.
Right,
So
right.
I have already done, I think, 2 to 3 episodes of NetGen. Till 2 to 3 episodes we will do on it. So I know about Team Edward. I mean,
Right,
hope
right.
one day I can talk to him, and I can
So
invite him
also
to
suggest,
TSP.
yeah, also suggest to bring few more peoples like Tim Edwards and Mohammad Qasim, Andrew, right? Or do
Matt
bring.
and him both have not accepted. I'm following them. They have not accepted my invitation. So I'm waiting when they will accept. So I will send message that please, if you can join TSP. let's have a session with you, because these people have done great work, and their vision that can encourage so many more people.
Right.
And
Exactly.
obviously the kind of experience they have,
Right.
that's
Right.
more than, I mean, monetary investment. It's an intellectual investment, kind of.
Absolutely.
Amazing
Absolutely.
people. So would love to talk to them. Hope I get chance. And yeah, Europe has this kind of culture. I love that. Few episodes, I think I have interviewed last, Dr. Mary Haley from Finland. She had done research, a PhD in material science, and she had run one fab lab successfully. Now going for another one. So
Wonderful.
mm, so I have talked to her. Okay, so when you are first, there is a comment come. Great. Shubham has said, "Hi Shubham, thanks. You are watching this, and at I don't know at which level you are. Look, Marmik is there. He's a very inspiring story. Get inspired and do something." And so, what kind of challenges you are facing while you are running Monk9?
The first challenge was the acceptance of deep tech technology, in particular our ecosystem. So if you see the yesterday's speech by Piyush Goyal, the
Exactly.
that we need to have deep tech, but I have been explaining this to many people from a very long time. uh, we need actual innovation, right? Not just me to startup. We need to have our own innovation, and we need to identify our own problems and solve it. So biggest challenge was to convince people, but I have been fortunate that now there are a lot many institutions, incubators, investors directly interested in deep tech. So initially getting funds for starting this facility was the biggest challenge, right? Identify talent is no problem because India is filled with talent. If you try to look, you will find talent. India
Mm,
is really great in terms of talent, and I have identified a lot of people, PhD in physics and nanoscience. Some of them are really good in, they have worked on semiconductor fabs before, so that was not a problem. But you know. Initially I need some capital. I started with my own capital as a
yes.
Monk Technology started as a bootstrap initially. Then we there was a some competition where we participated, and IIT Delhi accepted as their incubator. Then we pitched around 4 times to IIT Delhi, and there were professors from their physics department, the nanotechnology department, and then IIT Delhi became our first incubator. And from there, we also applied for Startup India Seed Fund. We received a really nice grant initially from IIT Delhi, and that was the catalyst for us to build this facility. So we started with a very pilot manufacturing where we didn't had the capacity to purchase ion implanter kind of a thing, right? They are very
Expensive.
expensive.
Very expensive.
So we created a process where recipes are our, but some portion of the process done on other fabs, right?
Mm.
uh, this is how we started, and then we decided that let's move towards uh, volume manufacturing. Now we are entering into volume manufacturing. We already started building a fab which is in Rajkot city in Gujarat. Then we were fortunate that we identified a venture capitalist. His name is Utpal Doshi. He is
Mm.
very much focused on India's growth in manufacturing, particularly
Right.
innovative manufacturing, and he's also very focused on deep tech. So and also when you are creating really nice things, the challenging part is the multiple roles you have to play, right? So I was keen on technology, but I was also requiring some support for workout on many problems this company is facing, like financial, then structuring it, operational, and anything. So I asked my childhood friend. He was having experience from Ernst and Young and Accenture, and he was handling a large team. So I told him, Ghanshyam, please join me as a co-founder, and he joined me as a co-founder. And then I told Bhai that you invest in Monk Technology and also become our strategic advisor. So he has like 25 years of experience in finance as well. So you need combination of technology, operations, and finance when you actually need to run an organization. So these were the challenges. Training was also a challenge. Sometimes I took help of some industry experts who are like 20 years in the industry, and arranged training for my team. So they train some of their tips and tricks, and even some of my team members solve their doubts with industry experts. So this is how we solve our problems. But I like problems will be there every time. We are ready to solve them on a regular basis. We call ourselves problem solvers. So that is a we call it daily routine.
Yeah, actually, we are problem solver. I
Yeah,
mean, what we are in technology is actually problem solver.
right.
With technology, we solve different problems. So I was going through your website, and I found few things like you are customized, focuses on customized microchip. So how your technology is different from others? I mean, what you offer differently? Like that, what you said, legacy node and advanced technology, is that one, or anything more is there?
So basically, we can take small orders as well. So if someone want to do only prototype, not the volume manufacture, we can help them out. We also use open source EDA tools, and we have our own standard cell library. So you don't have to get the license or get things required to invest anything upfront to just to complete the design. Then we also focus them to introduce application specific ICs to their product line. So we have customers from chip design company as well, but we have customers in product development companies as well. And we recommend them to use application specific ICs to give more features to their product instead of using general purpose microcontrollers or anything. So if they have ASICs in their product line, they have an edge over the competition. They provide way more better product compared to previously what they were making. Particularly IoT products, particularly drones. Some of them work on medical devices. Some of them work on industrial automation like PLC, programmable logic controllers, with application-specific modules and IPs. So this way, you create a really nice product out of your existing facility. And if you look at the embed level, like you have a microcontroller, then you have another IC for UART converter for your flash and all that. If you put everything on one single SoC, you reduce lot many things from your board, and you also improve your performance as well as you improve your cost and everything. So we focused on that particularly.
Okay. So once the ASIC is done, so you also take the things to how it will be placed on a board, or that final stage.
Right. So we
I mean,
have
after the chip is done, it will be part of a board PCB, a
right,
small
right,
board, a big
right,
one, depending on the application or the product, final end product or consumer product. So you
right.
also take part in that guide on that part also.
Right. We have to help them out because some of the customers are introducing ASIC for first time, right? So for
Uh,
that, there is a like a pre-manufacturing support, then manufacturing, then there is post-manufacturing support. Post-manufacturing support also include post-silicon verification to embedding
hmm.
to creating firmware and deploying. And pre-manufacturing are like we help them for EDA tools, we help them for standard cells, we help them to get through the finish line from RTL to GTS. So this is kind of kind of a turnkey kind of a thing where
Okay.
initially we have to educate our customers as well.
Mm. So no, actually my question is that for that, after the ASIC is done, I mean, including it in a PCB, and that part you do it in Monk9 facility, or some collaborator is there for that PCB assembling and all that thing is done with other some other people, or you
So
do it in Monk9?
no, no. So basically, this embedding part comes with our customer. We don't
Uh,
have responsibility for that, but we support them, right? We provide
uh,
all the necessities which they require to embed the chip. So we help them
uh,
out, but that's their responsibility. Some of them do in-house. Some of them have hired some other embedded companies who help them out with this kind of support. But we provide all the necessity and background data and all the required information they need to complete this.
oh, so actually the first time handling for those who are new to the field. That's really good,
Right.
because as long as this thing India is started. India has started quite late in this journey, and there are so many first timer who are having planning to do something, although has some hesitation. You are helping them out with this, just to overcome this hesitation and be confident in the field. That's a great job. I mean, apart from your job, you are doing something extra. That's really good. So you are developing on 130 nanometer PDK. So how it's are you collaborating with some research community, and what you are doing? I
So
mean, collaboration
initially,
is there.
right, right. So no, we that is the main part that Monk Technology has its own recipe and our own standard cells, right? It
Okay.
is different from the industry legacy technology because it, as I initially decided that we'll follow the regular process for that particular legacy node, but then we realized that if we introduce a little bit advanced technology, we have edge over the floor efficiency of the manufacturing. So for that we created our own standard cells, right? And 130 nanometer is a very 130 and 180 as well. So these technologies have their its own advantage, particularly if you look at their analog capacity, right? So you can create really nice analog ICs using them. You can also create really nice mixed signal chips using these technologies, and also fabricating them is not a big challenge compared to FinFETs and all other high-end technologies. So overall, it was a really good thing that we were able to complete all the missing pieces, and of course we had to collaborate with lot many experts, but there were no such expert who knows the whole thing, right? So there were experts, they know a particular thing. Some of them know only deposition, some of them know only etching, some of them know only lithography, some of them know only CMP. So that
Mm.
missing and connecting the dots, getting all the ducks in the row kind of a thing was done by Monk Technology.
Okay.
Particularly we had to do like trial and error sample processing. So we did around 75 wafer processing way before we did the first customer project. So for that 75 processing, we had to do a lot of trial and error for finalizing our standard cells. What N gate should be, what combination of AND gate and OR gate should be, like that. So that particular was a challenge, and we had to do trial and error at certain point of time. When we're pretty sure that these are working perfectly and giving us the right parameters, we selected the library.
Okay.
So this is how we
So,
get that node. Yeah,
okay. So you are also working on RISC-V based processor. So
right.
what's your approach, and what's your I mean, planning with RISC-V? What do you want to do? Uh,
So basically,
just
like
give us general idea, because we are not interested in any. Don't reveal any secret. No, no. We
that's
would.
so basically, no, it's nothing like secret, because we teach a lot of things in RISC-V as well. So I came across RISC-V through E-fabless Corporation, and of course I was not able to afford ARM at that time, right? I cannot pay that $75,000 license fee to ARM. So RISC-V was the only option I had. Then I realized that using RISC-V, you can create anything, right? You can create your own CPU, or you can create your own NPU. You can create your own protocols and peripherals and everything. So we see RISC-V as the game changing in the semiconductor industry. If you look at the last 3 years, lot many tape outs happened in RISC-V, and just last 2 years, you see there are end user product available with RISC-V, right? So I tell you right now, 70% of microprocessors we create have RISC-V, uh, you know, RISC-V architecture. So that's the future. Yeah.
I mean, this is this time. It seems that this is a second movement against
Right.
this
Right.
typical license Raj thing. Open source things are basically, it's a revolution. It's a movement against all. I mean, you have intention to make something good. You don't have money. Okay, go for this open source thing, and we all are using this Linux. Linux is also open source, so it good. It
Absolutely.
feels good.
So at certain point of time in information age, there is no such thing as secret thing. It's all about skills, right? So
Yeah.
risk. Yeah.
And you are also working on neuromorphic chips. That's interesting.
Yeah,
I
yeah.
mean,
So we
tell
have
us.
not completely explored the power of analog. So whole world works on analog, right? Only humans have digital world. Otherwise, the whole universe is analog, right? So analog has its own benefits. Analog has its own capabilities. If you look at the real world to digital world connection, you require ADC, analog to digital converters, and digital to analog converters. Otherwise, you cannot, connect to some of the sensors, and you cannot connect to the world, right? For that, if you introduce a neuromorphic processing, you will get way more advanced processing what digital can have at any point of time. So we did some of the research on that. We have a plan to publish a research paper on this particular thing which we are working on. So me and my three students working on this part, and we will publish by maybe end of this year, and we'll publish this research paper on neuromorphic computing.
Any patent till now on anything?
In neuromorphic, we are still in research phase, but first we'll publish a research paper, and once we have a viable commercial ability or something which we can do IPR, we'll definitely file an RPR. But the next step would be a research paper first.
Great. When you publish your paper, obviously you will share that news in LinkedIn. Also tag Tech Simplified TV, because this algorithm is not really very reliable. Not every time I get notification of my every connection. So please tag Tech Simplified TV.
Absolutely.
I would love to say congrats to you and your team, because it's always feel good to get connected with people who are really want to do something good and something new. Uh, when I'm surrounded by such people, I get more energy to do some really good work. So it's
Absolutely.
one
And
way my benefit also. So please tag
yeah,
Tech
yeah.
Simplified
So
TV.
that is a benefit. When we taught around 3,500 students, some of the students came to us that, sir, we are researching on this. Would you help us? Would you become our mentor? So a lot of students have really nice ideas, and they're willing to do a hard work on that. So sometimes we collaborate like this. So some of my students are already a team leader in Monk Technology. They attended my boot camp, then learned few things, then did internship in Monk Technology. Now they joined as a VLSI engineer, and then they are now team leader. So some of them are working on other research papers as well, and we promote research at Monk Technology very much. Right? If any of my ecosystem, regardless of their background, if they have any idea and they want to research, we support. It's simple
Great.
as
Great. So Monk9 has now at that stage where at least at small level commercial production, you are ready for that.
yeah, and we'll also have a really nice big team very soon. We are under recruitment phase right now. So
Okay.
we are also recruiting more
So
on
are
that.
you connected to Startup India or anything? A
Yeah,
DLI
yeah.
scheme? Have you applied for that?
So basically, we are have applied for specs, but we are waiting for specs 2.0 to introduce, and we are also planning to apply for Gujarat Semiconductor Mission as well, and we are
Okay.
also exploring other states policies as well. So
Yeah,
yeah,
Gujarat has a separate state policy. That's really good. I have
right,
talked to Nikul Shah, founder of
right,
Indisemic,
right. He's a good
and
friend. He's also like connected with the ecosystem as well, right?
they have completed 2 years, and they have published a booklet with 100 projects with Arduino. That's a great contribution, I would say.
Right.
Actually, no,
He's also very
I'm
nice working on RISC-V course as well.
yes, yes, he told me. And have you watched the video post budget address where PM Modi has addressed allotted money for deep tech? And have you watched that video? That's available in YouTube. So
Yep,
I
yep.
think there are scopes for startups to get fund if the project is really good. The funding is there now. Government is very so pro. Government is we have got luckily.
Yeah,
So
exactly what you said. That of course we are late, but we can start at any point of time, and we have the talent. We just needed some platform and support, which is now government as well as venture capitalists are providing.
mm,
If you look
mm,
at last 2 3 years, even after pandemic, there are lot many deep tech VCs have emerged, and they are putting a lot of money on research, and
mm.
that is definitely going to change the landscape at all.
Yeah, even our minister Piyush also said that. Yeah,
Right.
and what's your about your that 30 angstrom node,
So basically, it's
and you named after Netaji? Why?
Netaji. I wanted that my students remember Netaji, so that's why I wanted to have that node. So basically, we are not using the extreme ultraviolet based lithography. We are exploring other ways to create 3D structures at nano level. There are for commercial 3 nanometer or 5 nanometer production, you require to have multi-patterning DUV or less multi-patterning EUV. But there are other ways to create 3D nanostructures, and they're
Mm,
also viable to do at large scale in many ways. So we are exploring that. It would take some time for us to actually create them into a commercial viable thing. Right now, we just did some research on that. We process some of the samples, but we are working on that it will help future technology to be have 3 nanometer of node without using extreme ultraviolet based lithography. Remaining all other steps like deposition, etching, we already have like atomic layer depositions and ICP-RIE, and even atomic layer etching is also there. But for lithographic part, and even CNP can do up to 1 nanometer of precision, but for lithography we have
lithography.
so yeah, we have explored other
You
areas.
are looking for a new recipe for that lambda part. That
Right.
lambda.
So lambda part, we are not going into light based lithography. We are exploring something else.
And that iMac and ASML, the machine for extreme ultraviolet, that's almost have a size of a blue whale, I guess. A huge
And
machine, and a
that
very expensive, obviously.
is not also accessible for many of the countries. For example, even if you want to buy it's a $300 million equipment, you need to have $1 billion infrastructure to handle that $300 million equipment, and there is 7 years of waiting. So
Unfortunately, monopoly.
monopoly. So better to explore more areas. And
Yeah, obvious, and
in fact,
that's why you are reading patents and research papers.
yep.
And
So
once your recipe is there, we will get another research paper from Monk9.
of course, that's likely to happen.
Yes. So, what are the facilities you are providing? So, what are the steps? I mean, if you can share, what steps you do?
So,
Deposition,
uh,
isolation, what?
So we have the recipes for LPCVD. Initially, we started with LPCVD. Then we have for PECVD. Then we have for RIE and ICP-RIE. ICP-RIE particularly for shallow trench isolation. Then we have multi-patterning process for direct lithography. So direct writing lithography has the limitation up to 400 nanometer or sometimes
Mm.
300 nanometer critical dimension, but we have a process to do a multi-patterning using direct writing lithography. Then we have our own recipe on some part of creating very efficient vias, particularly V1 to V4, and particular this deck has like 5 metal layers what we work on. So these techniques are really nice. We provide the whole support system to our customer. If it's a chip design company, we provide them EDA and PDK. So in our EDA, you can do RTL to GDS, and once you have that GDS ready, we can just fabricate that. And then for a product company, we help them out with identifying how to do the design collaboration with some chip design companies or fabless companies. So so far we are helping both chip design companies as well as product companies.
Actually, advanced node, most of the chip or majority of the chip we produce every year, most of it is majority of it is from legacy nodes,
Right.
not the advanced nodes.
Right.
Advanced node is kind of a status symbol, how advanced we are for these companies, although their majority of their revenue comes from the legacy nodes.
Legacy node.
And
So whenever this 180 nanometer and 350 nanometer fab started, particularly like TSMC and Global Foundry start, they still running these fabs, right? Still TSMC 180 nanometer is available.
mm, mm,
Global Foundry is available. They never close these fabs because of
mm,
the market requirement, right? And
exactly.
of course, when you work on a really nice idea, you initially tape out on legacy technology, then you slowly move to higher nodes,
Mm, mm.
looking towards the risk as well. So yeah, it's a very viable thing.
So you are, as your website says, you are working on multiple type of technology like silicon, compound semiconductor, and networking like 5G, 6G. So how you handle all of these things, multiple things, not a single type of work.
So basically, compound semiconductor we do not do in our facility. We do it on some other academia facilities and our collaborative fabs where we
Okay.
utilize part. Uh, Compound semi is not our commercial list at the moment. We are commercially we are completely focused on silicon, but we
Okay.
have explored silicon carbide and gallium nitride previously because of their
Industrial important.
industrial importance. About the 5G and 6G, we identified that we can do SDR based chips, software defined radios, which can make 5G possible. We also did some mixed signal processing with MIMO, multi input multi output for multiple frequencies. Then we realized that it is also possible for many of the companies to introduce such kind of IPs. So we wanted to promote fabless companies to create IPs for this 5G technology. We also want them to make some IPs on Navic. So Navic is kind of a future.
GPS.
Yes, Indian GPS. So we want our customer base to have that kind of projects as well, to
Great.
explore part. And we are still discussing with some companies who are working on encryption for 5G. So of course that will require way more higher nodes, but better to start working on them right now.
Hmm. And what is the most tough part when comes to the fabrication for these 5G, 6G chips? What are the most tough in fabricating them?
Initially, the it would require technology higher than FinFET. right? Particularly for 5G, it's not that much viable for legacy technology. Second
Hmm.
thing is the complexity of their mixed signal design, right? So basically these are chips which also require a lot many simulations as well as verifications way before even you do fabrication. At fabrication level, it is just another GDS for us. So basically, it doesn't make any huge difference
Okay.
on fabrication. But before
At
fabrication,
design level, it's really tough. Okay, got it. And what is your? I mean, two question, separate thing. Like Europe has a facility sharing concept,
right, right,
and is it possible in India? I mean, Monk9 is doing something like that. I mean,
right.
some kind of community work also you are doing, educating students and leveraging your setup for startups, other startups, and handholding them. So you are doing. Do you think that that kind of culture will spread across India? Because India is a huge country and with huge population. We are a vast country. So, what's your opinion about it?
That is really required. If you look at the Fraunhofer Germany, Fraunhofer IPMS, they give access to research as well as enthusiasts to their facilities, right? Now it has been started. Like if you look at the IIT Delhi, IIT Bombay, IIC Bangalore, all of them provide you, access to their fab at certain cost, and its costs are very nominal, right?
Hmm.
And we have utilized such kind of things in Europe as well as in India as well, right? So there are a lot many private as well as government facilities which you can access, and if you're working on an idea, you should access that, right? Of course, Monk is providing that access. So if anyone has a research idea, we will provide such things. Some of the universities we have, signed MOU where their PhD students can come to our facility and do their research. We provide them full support on that, and I believe all deep tech should keep themselves open for such kind of research access,
Yeah.
because those academia and those access were available for me. I was able to build Monk technology, right? So that's
Hmm.
a thing for like some of them should give access to such kind of clean room where you have extra space. You allow some startup to work on clean room, so they don't have to build a clean room. So that kind
Yeah.
of support you should give them. Like someone is working on battery research, someone is working on other part of nanotechnology, right? Nanotechnology is the future, so it's not on
Hmm.
limited to semiconductors. But so for that, if they want to do something like atomic layer deposition on something else, or like they want some their idea to be processed, of course Monk is open. And I also request other startup watching should be open for such kind of access.
Great. And do you think that we can be self-reliant on this manufacturing part one day? I mean,
Not
in
one day. We already started. See, chip design is always there. Like from 2 decades, it was there, right? Indian chip designers are having really nice grip over the market. Now fabrications are opening, right? SCL Mohali is also expanding. Tata is making the plant at Dholera, Gujarat. Monk is also
Mhm.
there. Some startups called Amidst Semiconductor working on MEMS and sensors. Some of them working on power semiconductor as well. So fabrication is also opening, and if you heard the news, lot many offset and ATMP plants are also coming up, right?
Yes.
So and also there is also a very good incentive for embedded and component manufacturing as well. So
Mm.
if you look
Mm.
at the whole ecosystem, from idea to silicon to embedded to end user, everything is going to being manufactured in India. Personally speaking, I have seen some of the plants. It's already started. The
Great.
whole ecosystem started. A chip design in India, fabricated in India, packaged in India, embedded in India, and also product that PCB in some product also. So everything is done in India. That products are already in the market. So it's already started. We just have to expand this.
We would love to see that made in India tag on the products.
Completely. Make in India, completely make in India. No other components from other countries. Complete
Exactly.
self-reliant. Yeah.
Yes. Exciting days are ahead.
Absolutely. That is the reason we and my co-founder has a really nice career, and we took more pressure starting Monk Technology, but it's worth it.
That gives a happy feeling, no? Every
Yeah,
day.
of course,
Okay.
of course.
Good day.
After
It's a good
end,
morning.
yeah, end of day, we are very much satisfied that we are doing great thing.
Exactly.
That is, nobody can buy this thing.
Yeah, no one. So, what is the biggest challenge? Still, we have a lot to do. And what is the biggest challenge for startups in India?
Uh,
What
I
do you think?
personally, I personally think startup founders should not quit very easily. I have seen lot many startups closing down. So my personal, opinion is that if you require to pivot. If you require to do joint venture or merger, do it, but don't quit. Right? Of course, there are a problem, but you know that you are solving something. Then challenges are very small thing. When you're solving a big problem, then of course challenge is not opposite of success, it is part of success. So just want young startups to just don't quit. Again, I also am not in too much favor of student startups, because I personally believe they need to either join another startup, join a team, or have some job initially, then do a startup. Otherwise you won't be able to face the challenges are huge.
Monetary monetary
We
challenge is a big challenge because family responsibilities are also there.
Right, so we are going to face affection from the US recession. Is about to come, whether we believe it or not, it is about to come. So of course it will going to affect the whole globe, and it will also going to affect India as well. We need to prepare ourselves for such kind of challenges, where sometimes funds won't be easily available for startups, tech won't be easily available for startup, workforce won't be easily available for startup. You need to have that kind of insight that you identify the solution. Sometimes solution is just in front of you, just need to have that vision to identify the solution, don't have to actually solve it, right? So
Yeah.
Modi ji has said, like, convert your आपत्ति को अवसर में बदलने की attitude रखना चाहिए. That's the only thing.
His words are very powerful.
Right.
Amazing words. His selection of words, that's amazing. I don't know how in every speech he connects so many people. Young minds get so much in.
That is the reason
Words has immense power.
right, that he has faced all these challenges which you and me and other people are facing. So he knows that what we are facing, and he also knows how he solve it. So a person who has being a fighter and a problem solver in their life, they can motivate others easily,
Yeah.
because he has faced that problem, he has faced that challenge, he has understand that it is solvable, and he will just you need to identify the right attitude. Otherwise it's going to be challenges always.
Actually, he has traveled through different landscape of life for many years. Have seen always he says that I have stayed every district of this country at least 2 days as
Right.
a science sevak. So he has huge experience and knowledge of direct human experience, people experience, amazing experience, and he has very deep spiritual understanding also.
So
That
if you look
is,
at the history of Indian politician, he has the most utmost respect towards technology, right? When he was chief minister in Gujarat, he started using social media to
mm,
vast their
very updated.
is very easily. He's also open for all type of technology, quantum,
Mm,
सबको आने दो, quantum, AI, everything is open for that. Even at some point of time, they were also looking for cryptocurrency in as well. So my point is they are open for technology, and
that's the
they are
benefit.
benefit. Yes, yes,
Yes,
and
benefit for
and
youngs.
he also understands that technology can solve the problem. We are 1.42 billion people. We have our own challenges. We cannot follow developed countries because they have their own level of challenges. Uh, have we ever thought 15 years back or 20 years back that such kind of companies will emerge and make microchips in India? We were never thought of that.
Let me tell you, I was doing my master's and semiconductor was my favorite subject, though communication and other things were there. So I enjoyed those 2 years, and compound and all kind of semiconductor I love. So I was doing my project in Shaha Institute of Nuclear Physics. And that so many scientists are there, all our professors, scientists are there. So research associates. So they were talking here. So semiconductor is your favorite subject? I said yes. But India has missed the device bus. I was so upset. I said, oh my God. No, I cannot do anything. I mean, this is my favorite field. No, no, no. We have already missed that. That was in 80s, late 70s. We have missed that. So I was quite upset with that. And again, I joined industry and working. And again, then the opportunity came that government is doing so much. And yes, we are late. Although it's always late. I mean, it's good. We have so many models, and then we can navigate and we can assimilate them in our system. Okay, open source system is also there, a licensing system, everything. We can accommodate everything. It's a vast country. We have huge manpower. So many engineers are coming out every year. So we can have a system in an ecosystem where we can accommodate every kind of models which is existing in different corner of world. So that advantage we can get. Obviously,
Absolutely.
we are starting late, so we can learn from others. There is no hesitation in that. We can learn. We can
Yeah,
improvise it in our way. It's very
right.
Indian jugaad way. We can do it.
We are
So
best
we
in
will
that.
have. Still, it works really good, Marmik. Jugaad
Yeah,
is a great thing. It
yeah.
gives. You have to have very wise mind to work in alternative way. Look at yourself. You are not taking any other modern way and still finding your way for 3 nanometer.
Yeah,
So
yeah, yeah, absolutely.
do the same work in a less cost effective way.
Yeah.
So
In a matter of time, see, honestly, we do not respect each other as a Indians. If you like any Indian engineer go to North America or Europe, they have been seen as a very respectful people,
mm,
because Indian engineering itself is a way more comparable than Japanese and German engineering.
mm,
Right?
mm.
We just don't respect ourselves. That is the only problem.
Yes, yes, that is the only problem.
We need to respect our ASIC designers. We need to respect our verification engineers. And if you look at the global landscape, we have the highest number of chip designers, right? So why should not we lead it?
Don't know. Some problem. I mean, so many years of colonial history has some wrong things has came into our habit. So I think that's so. Which recent innovation excite you most in fabrication? Because you are reading a lot of research papers.
Yeah, so basically nano imprint lithography and particularly atomic layer etching. So that both excite me. And there is one more thing happening is particularly creating three-dimensional uh, uh, three-dimensional structure where you have power supply from bottom, and then you have the interconnects on the top, and the transistors comes in the middle there. So this technology really excites me.
Are you saying
Sorry?
about buried layer?
Yeah.
Okay. Actually, I had made one episode for buried layer in
Buried
R&D track. In Tech Simplified TV, we have a track called R&D. So I made one on NSFET and another one on buried layer. Yeah.
So maybe in
So
future, we won't require different process for creating the memory chip and the logic chips. There will be technology where we'll be creating both on a same process thing.
mm,
So usually memory chips takes around 192 layers, and highest 7 nanometer, 3 nanometer has like 44 to 48 layers. So maybe in future we'll have similar layers for all the things, and we would be creating a transistor as well as the capacitor side by side. So
Great.
that is the future.
And
Yeah.
and are you facing any problem while scaling up your whole facility, because you are in a field where giants are there, big giants are.
Yeah, of course. So basically, I don't see giants as their our competitors because they cannot take small orders, right? Because they are very giant. So it's a story of David and Goliath. That David had its own advantage to moving towards a way more higher technology than they that all these Goliath companies are heavily invested in some technology. They can move, but they cannot easily move towards cutting edge innovation that easily, right? They require the a huge capacity to just move. But a small company has that advantage that we can move towards any cutting edge technology. Yeah.
Are you connected to Dr. Mary Haley?
In LinkedIn, yes.
Yeah, and actually she says the same thing
Oh,
in her post. Same thing.
oh, wonderful.
Because you are the second person from fabrication facility I'm talking, so
Right.
you are saying same things.
All
So
fabs will say that because they have sometimes, for example, I tell you one example. I'm not sure how much time we have, but like I just give you a quick example that
no, 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 take your time, take your
that
time, eat our technology cafe, take your
right.
time.
So just after the second or third wave of pandemic, they introduced US chips act and bring all the companies to manufacture their wafers in USA. They provided some billions of dollars of revenue, and lot many bigger fabs were coming up, someone in Arizona, someone there in like Texas and everything, right? Now what happened is they already invested really big in the fabs for 3 nanometer or sometimes 5 nanometer, and then Donald Trump came and they stopped the US chip act, right? They stopped funding that particular time. Now big fabs are stuck. Some of them are delayed more than 3 years of their plan, and there is a risk when they actually start the production that technology would be older, right? So that is the thing all fabs worry about, right? And that is why we choose legacy node, because there is no worry about demand. It would be there for next 10 years, right? If I invest heavily on 7 nanometer or 10 nanometer right now, we don't know whether it is going to have that demand or not. But there would be a
Hmm.
demand for power management IC. So if you have a 3 nanometer chip, you will require a power management chip of 180 nanometer to power your high end chips. So that is kind of a thing, Goliath, David and Goliath story we tell everyone.
Exactly. So finally, what's your advice for other those who are thinking about their starting their startup, to jump into that field, and obviously about those enthusiasts who are planning to join the VLSI, for both? Your
Uh,
suggestion.
so if they are joining VLSI, it's a tremendous opportunity coming up. As I initially said, that overall requirement from general micropurpose to application specific are moving fast. Algorithm based, ASICs are very much in demand. People don't want to stuck their performance in general purpose thing. So we will require more VLSI engineers in future, even for verification, even for designing. So there are lot many opportunities for chip design companies. Lot many fabrication facility will also be available. Lot many nodes will also be available.
Hmm.
Second thing is I also suggest them to get a early feedback on their ideas. So they should have a small network of industry experts, as well as, and I will also suggest that everyone should have a networking these days, very good networking, not
Hmm.
particularly for semiconductor. So even I am also connected in the industry, but I work under the radar most of the time in the industry. I don't talk too much about things on social media, but I'm connected with multiple industries. I'm also connected with medical devices. I'm also connected with healthcare startups, energy startups, solar startups, even space startups. I talk to lot many space startups and try to understand their requirement for
Mm,
microchips, right? I also talk to some of the financial companies. I also talk to a lot many different industries like AI, or some of them working on very high end
mm,
mathematics as well. So you need to have just gist of some other industries as well. Being a founder, you cannot be just a VLSI engineer and start a business, right? And as an overall development, you need to have networking. You ask people, right? What we discussed, you need to ask lot many things. Yeah,
yeah, actually, all the streams are interconnected, not
absolutely.
very, and it's kind of market research you are investing,
Right, exactly,
because
exactly.
you don't know from where a idea spark comes. So
Yeah,
because
yes,
it's startup.
yes, absolutely. And if you look at the collective
Exactly,
knowledge is always better than deep knowledge, right? When you
exactly.
have a collective knowledge, you create really nice things. You have deep knowledge, that is good, but that will limit yourself as well. So have a collective knowledge. That is really nice thing to have.
Hmm. Good, really, very good. You are for how many years you are with Monk Tech? Three years, 4 years,
Started in July 2022.
2022, almost 3 years.
Yes.
Great. Okay, so we had a lot of questions, and we got all our answers. Had an excellent session with you, Marmik.
Thank
Uh,
you.
wish you all the best for your future. You are doing a great job. Keep spreading knowledge, keep learning and spreading knowledge at the same time. And obviously, these small setups and big um, target, big ambition should be there in our country, because India has embarked in a new journey. Young India,
Yeah.
we will, yeah, obviously. And since our government is so much supportive, we will do. We will have our everything of our own design, our
So
own fabrication, everything. We'll be
exciting time.
self-reliant. We will be self-reliant. No one can. Uh, I mean, we should not depend on anyone, and
Right.
our market will spread with products. This make in India tag. We will love to have those days. No make in other company, other country. Made in
Right.
other country, no. Made in India. We want made in India products.
Right.
That will be great time for us.
Absolutely.
Well, so anything you want to share, or any message, anything? I have asked
Uh,
so many questions. Anything on your side?
I just wanted to say what Vivekanand said: "Arise, awake, and stop not till you succeed." That's it.
Ah, yeah. ওঠো জাগো এবং লক্ষ্যে না পৌঁছানো অবধি থেমো না, that's in Bengali.
Yes.
In it's the theme of Mridul's life.
Right.
And in my case, it's another of his quote that used to be printed in our school diary. তুমি নিজেই তোমার অদৃষ্টের নির্মাতা, means you are the
On
maker of your
destiny.
yes, you are the destiny. So these two, we have two different, we work on two different principle, but always inspired by Swami Vivekananda, because I told you na, for first 6 years of our lives, he was in other part of West Bengal, I was in other part of West Bengal. Although we were part of those schools, my primary school was run by Narendrapur Ramakrishna Mission, and he's from Ramakrishna Sheba Shodon, an allied kind of institute. And
Right.
there is a temple of Swamiji Thakur. We respectfully and with love, we address Ramakrishna Paramahansa Dev as Thakur, and Ma, Sharoda Devi, as Thakur Swamiji, and Ma. Their idol is there in our temple.
Always in my, I need to blur the.
Yeah. Yes, in that CPU also there is a picture. I'm in the setup. There is a CPU, and on that there is three pictures together. Yeah, always. I mean, um, somehow, look how we get connected. I never knew that Marmik is inspired by Swami Vivekananda. You never knew that about that Munmun is inspired by Swami Vivekananda.
You never
Still,
know.
someone is there up watching us, so we are
Absolutely.
getting connected. Yeah, I'm so
Absolutely.
happy, just to get know that you are inspired by Ramakrishna Mission, their philosophy. I'm so happy. It gives, I mean, feel like I know you for so many days. I mean, it's not our first interaction. I know you. It feels like that. Great.
True, true.
One day we will meet and we will have a lot of things to share.
Absolutely.
Absolutely. Okay. We had a great session, Marmik. Thank you very much for sharing. Obviously, you publish paper, and when you share the story in LinkedIn, tag us. We would love
Absolutely.
to be a small part of your journey. Thank you very much for encouraging so many people. You are no, don't, please don't hold your hand. It's our privilege. I every session I learn something from each of my guests. It's a learning. It's a live learning experience for me. I enjoy doing TSP. I hope
Yes,
many people enjoy watching it. Uh,
yes, yes.
Anyway, so we will wrap up. Viewers, our today's episode had an exciting and engaging conversation with Marmik, founder of Monk9 Tech, and do us follow and like, share, and subscribe to the channel. Follow the Semiconductor Podcast. Thank you for watching up to this point. Thank you and bye for today.
धन्यवाद.